So for question 5, it says, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW over dt equals 1 over 25 parentheses W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. So for letter A, it says, use a line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, time t equals 1/4. So, normally we will use a point slope form for the tangent line, but since they give us t equals 0, it will be easier to do slope intercept. So we need to figure out what the slope will be when t equals 0, and so we will take it from the dw over dt. So it'll be what the hell? It'll be dw over dt equals 125 w minus 300. Since there isn't a t in this, we will have to plug in the 1400 that they initially gave us. Which calculating this will be 44. So now we know that this is a slope. The 44 is a slope after doing this. So now that we have the equation, now that we have this, we now have the equation, which will be W equals 44T plus 1400. So honestly, because we have the T equals 1/4, we just need to plug it into this, and it will become W equals 44 times 1/4 plus 1400, giving us 1,411 tons. For letter B, we need to find the double derivative in terms of W. Use the double derivative to determine whether your answer in part A is an under or overestimate in the amount of solid waste the landfill contains at time t equals 1/4. So pretty much what we need to do is, they already gave us a function in what to derive with. So it was dw over dt equals 1 over 25 in parentheses w minus 300. I found the first, I just distributed, so it will be dw over dt equals 1 over 25w minus 12, and then this I will derive. And when I derived it, it will be 1 over 25 dw dt. But that's only the first derivative. Now we need to find the second derivative, which finding that would just be 1 over 25 brackets 1 over 25 parentheses w minus 300. Now we just need to solve that, and here we get 1 over 625 parentheses w minus 300. So to identify if it is an under or overestimate, we must see if the function is concave up or down. To find concavity, we need to find the second derivative, and we already did that. So we know at first the landfill contains 1,400 tons of solid waste, and it does say that it is an increasing function. So we know that it's only going to get bigger. So we just have to plug it in, the 1,400, and we get 1 over 625 parentheses 1,400 minus 300. Knowing this, when we subtract this, it's going to be positive, and since this is a positive, the answer will become positive. And so if we do solve this, since the answer is a positive, it means that the function is concave up. This means that as it increases, it will continue to stay positive, meaning we have an underestimate. So we know that 1411 is an underestimate because W is always concave up. Since, keep in mind, the double derivative, while it's bigger than 0, on the interval for letter C, we need to find the particular solution when w equals w of 1 to the differential equation dw over dt equals 1 over 25 in parentheses w minus 300 with initial conditions w of 0 equals 1400. So pretty much what we're going to do is we only need to find the equation. So what we're first going to do is separate the dw and dt, and we will get so the next thing that we will do is just the derivative. So sorry. So pretty much from this, we just need to plug in what they gave us. We already have w, which is 1400, and we already have t, which is going to be 0. And the only thing we're going to do is just plug it in. So solving this, it will become which will equal the C. So now, knowing that, we only need to do w equals 300 plus e to the 1 over 25 t. And so knowing that, w of t equals 300 plus 1100 e to the 1 over 25t. And we know that the interval will be between 0 is less than or equal to t, which is less than or equal to 20.